Hey, it's Dr. Bob. Today we're talking about how food is inflammatory, and then we'll talk about the spectrum of the ways that food can be inflammatory. So there are actually a number of different mechanisms by which food is inflammatory. Some of it is direct effects on the gut, some of it is effects on the microbiome, and some of it is the chemicals in food and the substances that get absorbed into the bloodstream. So the number one way that food is inflammatory is if you react to it. So the body has 70% of its immune system in the gut, and that's where we do what's called IFF, identify friend or foe. So we figure out which bacteria are normal, which things coming through the gut we want to digest and chop up into little pieces for sugars and fats that we need for membranes and for proteins as building blocks of our enzymes and our muscles. And so through all that come other things like invaders and viruses and bacteria and parasites, as well as things that we may not have seen before. And then there are other chemical compounds like lectins that some people may react to that are compounds in plants that in some people may incite an inflammatory reaction or may cause direct damage to cells. So the number one way that food is inflammatory is if you develop an allergic or an immune food sensitivity reaction to it. So an allergic reaction is usually something like an IgE reaction, a classic allergy. You eat food, your stomach symptoms might be vomiting right away, but more common cramping and diarrhea. That's pretty intense and happens right away. And might also be more systemic allergy symptoms like stuffy nose, itchy eyes, red eyes, swelling of your throat, wheezing, asthma, or even anaphylactic shock where you collapse because you're so allergic to something. But a more subtle and probably more common type of food sensitivity is either a cellular-based food sensitivity or an IgG-based food sensitivity. And so the cellular-based food sensitivity is where lymphocytes or granulocytes, different kinds of white blood cells in your system, attack the food because they think it's foreign, or antibodies like IgG antibodies, where we tag that as something that's abnormal, and then the killer cells come along, and when that tag is on there, that activates a whole immune response and attacks that tissue. And so sometimes our body thinks that the food is something foreign. And when does that happen? Well, it often happens when the gut is damaged. So when the lining of the gut is damaged and the gut is leaky, then larger pieces of proteins and molecules and carbohydrates combined with proteins and fats, all those complex molecules that usually stay within the lining of the gut, in the lumen in the middle of the gut where they're digested and worked on, some of those leak through. So if the tight junctions that hold the cells in the gut together are no longer as attached, and there's been damage, and so the cells, instead of being right up against each other with a compound like zonulin or occludin that ties them together and fills in that gap, the cells are damaged and they may have holes in them. They may even be severely damaged and have large holes in them, in which case things can go through those holes. So fragments of protein that usually would get chopped up into little pieces like amino acids that we need as building blocks instead go into the system as larger pieces. When the immune system sees them, it goes, wait a minute, you're not supposed to be in my bloodstream. And so they make antibodies. The killer cells come into effect. The cells discharge DNA nets to wrap them up, and the body tries to attack and kill the invader. And that's the way that it can cause direct inflammation from that reaction itself. But another thing that happens is called molecular mimicry. And so when the body has its own proteins that look a lot like those abnormal proteins floating around in the blood that aren't supposed to be there. Let's say that fragment that gets through looks like your thyroid tissue or looks like your heart muscle. Then all of a sudden, you're not just attacking that molecule that's floating around in your bloodstream, but you're making antibodies against your own tissue. And that can cause an autoimmune attack. And so things like Hashimoto's thyroiditis can be a product of that. Even things like rheumatoid arthritis or other systemic autoimmune diseases. So it's possible that all those things can come into play and cause an immune reaction. So what else can cause immune reactions? Well, the chemicals in food can do that. So there are probably about 50,000 chemicals in our food that weren't there 100 years ago. And we know what some of these do. We've studied them pretty thoroughly. And a lot of them we don't really know. But some of them disrupt the microbiome, the normal bacteria in the gut. Some of them disrupt the surface layer. So they're disruptors of the microfilms of the microbiome. So we have these films of protein, mucus, cells and organisms, and they're like rafts. And so sometimes there are chemicals that come along, like carrageenan and polysorbate 80, that disrupt those and allow abnormal chemistry, abnormal biology, abnormal bacteriology to happen, where the lining of the gut is no longer as healthy and the microbiome gets out of balance. And the microbiome has more genes in the bacteria in our gut than we have genes in our own system. And so when they do all sorts of things, from producing vitamins to producing neurotransmitter and other signaling chemicals that we absorb and go to our brain and our nervous system and throughout our body. They also interact with the immune system, which is closely tied to the body and the what we call psychoneuroimmune system. So psycho, the mind, neuro, the nervous system, and then the immune system is strongly tied to that. So if you're extremely stressed, your cortisol levels are too high, you're way out of balance, then your immune system sets you up for other diseases, things like infections, but even things like cancer can do that, because the immune system is constantly in surveillance mode looking for abnormal cells like cancer cells. When it finds them, it wipes them out. So one of the reasons the cancer happens is not just that you formed an abnormal cell, it's that you formed abnormal cells and that they escape the mechanisms by which your immune system controls and wipes them out whenever they evolve, usually. So that's another thing that can happen. Another way that food can be inflammatory is the type of food itself. So for instance, certain oils are more inflammatory and certain oils are anti-inflammatory. So things like olive oil and the olive polyphenols in it, other monounsaturated fats like avocado oil, and to some extent, depending on the person and their genomics, coconut oil. So some of those things have strong anti-inflammatory effects, while others, like the omega-6 fatty acids, things that are found in things like soybean and cottonseed and many of the other commercial oils that are extracted with chemicals under high temperature and become damaged and oxidized, a lot of those are pro-inflammatory. And so one of the things that we measure in our practice is something called an omega-3 ratio. We try to see how many healthy omega-3 fats that a person has compared to the omega-6, which are the more inflammatory ones. And typically that ratio used to be 1 to 1 to 1 to 3, but now it's as many as 1 to 10 or 1 to 20 with 10 or 20 times more omega-6 fatty acids than omega-3. So those common omega-6 fatty acids like alpha-linolenic acid, those kinds of things are often part of the inflammatory cascade. There are a few omega-6 fatty acids like GLA, gamma-linolenic acid, that are anti-inflammatory. But in general, if you think omega-3 anti-inflammatory, omega-6 inflammatory, then that will be another way that will help you to tell kind of what's going on there. So those are a number of ways that food can be inflammatory. It's nice of you all to stop by, and we hope we gave you some education about how food can be inflammatory and a way to think about it that may help you avoid that inflammation and take one more step to being migraine free. Dr. Bob, over and out.